Now, I request Dr. Devika Devnath, HOD Electrical Engineering Department, TCA, to felicitate our principal, sir, Dr. Dibakar Dev, President of IIC. Now I request Dr. Dibakar Dev, President of IIC and Principal of TCA, to speak a few words and address the session. Sir, please.
Our speaker today, Mr. Meghnad Saha, when in our state, Tripura, a very few areas were covered by electricity. At that time, he was engineer. Now you are engineer, not engineer, you would be engineer. So today we will gather a huge knowledge how it is developed all over the state. He has vast knowledge on industry, how an industry work and how you will be suitable for the industry so that you can be placed in different industry. You will ask different question. It is a scope. You get a chance to meet with a scholar of this state in this field, engineering field. Today's lecture is very important and technology. This is also an important word technology because everything connected with technology. From ancient time when there was Iron Age, Bronze Age, that time there was technology. It is also technology. Wheel, this is also technology. Now our technology are changing only. It is emerging. But that time, once upon a time, there was technology. Now we have technology. In our future, we will only develop technology day by day and adopt new system how we can survive, we can make our life comfortable based on different using technology. So this is a great scope. You interact with our special speaker, very prominent speaker of the state, and hope you enjoy the session. And I wish the success of this session. Thank you for all the coordinator of this program and the Department of Electrical Engineering and IIC. Thank you. Thank you all. Thank you, sir, for coming here and interact with our students.
Thank you, sir. Now, without further delay, I would request our speaker, Mr. Meghnad Saha, sir, to please continue the session.
শোনা যাচ্ছে? Audible? Am I audible?
অনলাইনে কানেক্টেড আছে এই জন্য এখানে 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 শোনা যাবে না সাউন্ডটা।
হ্যাঁ,
ইউটিউবে কানেক্টেড আছে।
ও আচ্ছা আচ্ছা। Good afternoon to you all. Actually, this is a great opportunity. I am indeed delighted for having uh, received this opportunity to share with you some salient features of the present power and energy scenario of the country. As I was told yesterday evening by Tushar to say a few words on this matter. Actually, our principal sir and others have praised a lot about me, but I am not of that worth. Anyway, I have worked in Tripura State Electricity Corporation for over a very long period of time. And since my retirement, I have been engaging myself in different sectors. And till today also, I am working, as already said, that I am a member of the BOD of TIDCL. Moreover, I am associated with some other companies too, some industrial sector organizations. Anyway, today with the institutes Innovation Council and the Electrical Engineering Department, they have organized a very beautiful program to observe and celebrate the National Technology Day. The significance of this day has already been explained in a very nice way by the speaker. So I need not to elaborate on that thing. What I want to say about the power and energy scenario of the country. India is the largest democracy of the world, as well as India's population is the largest population of the globe, because our population has already exceeded 141.72 crore as on today. As on today, maybe I am not very much updated. Maybe so. Our peak power demand in India is estimated to rise by 7% on year basis. And this summer, this peak demand will touch 260 gigawatt. You are very well aware how much is the 1 gigawatt. See, 10 to the power probably 12, probably, if I am not wrong. So 1000 megawatt is 1 gigawatt. So now, by this summer, the peak demand of the country will reach, as estimated, to 260,000, 260,000 megawatt. Okay, because 260 gigawatt, you can multiply by another 1000. Installed capacity of power generation is around 4,26,132 megawatt as of now, the total installed capacity throughout the country. Now, during 2023-24, 9,943 megawatt added, of which 1,674 megawatt from fossil fuel sources and 8,269 is from non-fossil fuel sources. Now, why I have specifically mentioned this fossil fuel and non-fossil fuel, I will come later on. How fossil fuel is affecting and how non-fossil fuel is advantageous to us. Renewable capacity of 7,569 megawatt added during 2023-24. Okay. Now you see, I will give some electricity sector of India. Installed capacity, you see, 4,26,132 megawatt. Next, production, that is in terms of terawatt hour. How much? 1719.442 terawatt hour. You are well conversant about terawatt hour. I did not explain. Average electricity use. Why I have said that India's population is the largest population of the globe, but still our per capita consumption in terms of energy is much lower than many developed uh, countries of the globe. It is only 1,327 kilowatt hour. Okay, and TND losses is greater than 15%. And just I am giving some scenario because today this is a subject. Sectoral consumption. Which sector consumes how much? Residential 25.77%. Industrial 41.16%. Agriculture 17.67%. Commercial 8.29%. And traction 1.52%. I am just speaking all about all these figures because today a scenario is to be presented to you all. Okay. Thereafter, I will come to my actual presentation. India's electricity generation was heavily reliant on coal. If you take figures from Central Electricity Authority or the apex body of the country regarding electricity, you will find that more than 75% of the entire generation comes from fossil fuel. And coal, you know, coal-based power stations, they contribute in a large quantity to the entire generation capacity of the country. Then natural gas 3.8%. In Tripura, we have natural gas-based power plants. All of you know very well because in Tripura only one hydroelectric power station is there. It's a small hydroelectric power station. Rest of all the power stations are natural gas-based. Then your nuclear energy 2.9%, oil 0.3%, renewable energy 21.5%. Now, government, this is very important. This portion is very important. I am just reading it out. Government of India declared its efforts to increase investments in renewable energy. Under the government's 2023 to 2027 plan, National Electricity Plan, India will not build any new fossil fuel power plants in the utility sector aside from those currently ongoing. No fossil fuel plant will come up in our country because that is related to GHG emissions. All of you know very well, greenhouse effect. So it is expected that non-fossil fuel generation contribution is likely to reach around 44.7% of the total gross electricity generation by 2029-30. Non-fossil fuels. That is the future of our country because we have to ultimately reduce the fossil fuel generation. I think all of you have understood what I have said. Yes or no, please tell me something.
Yes.
Okay. Now, share. I have fossil fuels share, total installed capacity, non-fossil fuels. Just I have given some tabular form information. See, region-wise and region-wise, western region, southern region, northern region, eastern region, northeastern region. 1,48,129.82 megawatt. It is 35. It is 35.04%. Then southern region 1,18,540.12. This is around 27.86%. And northern region 1,07,716.52. This is 25.31%. And eastern region, 45,088, 10.59%. And northeastern region, 5052.36 is 1.197%. So this is the contribution of region wise to the entire power generation capacity of the country. You see, power sector at a glance, all India. This is the figure Central Electricity Authority. Okay, you see, installed generation capacity sector wise. Central sector percentage. This is very important. You see, private sector. Should I go to the next? Energy scenario of Tripura. Hydro 10 megawatt, gas 1067 megawatt, solar 5 megawatt, total 1082 megawatt. Now, this 10 megawatt, actually it is 10 megawatt, but PLF is very bad. And in fact, this power station, Gomti Hydroelectric Power Station, was probably commissioned in 1975 or 76, if I remember correctly. It has outlived its life. Now there is a scheme for total renovation. So if that scheme is being implemented, probably the PLF will go up. In fact, Gomti Hydroelectric Power Station was basically designed for 50 million units of energy per annum. Okay, 50 million units. That is designed. In this gas power plants, it includes all the power plants of the state: Agartala, Monarchok, Boromura, Rokia. And this is the solar photovoltaic project. I think many of you might have gone to Monarchok and have seen. Have you seen 5 megawatt solar photovoltaic project? So this is this. Pardon? Where? Power cut. Power cut nowadays, very often power cut is there. Power cut is always there. Because 100% reliability, achievement of 100% reliability is a very complicated, tough subject. Given the situation, given the terrains, given the geographical conditions, given many factors, right from quality of materials to quality of manpower to quality of practice and quality of services, all these things are related. But even then, the reliability index has gone up to some extent during the last few years. If you look at, say, 15, 20 years back, you remember what was the condition. I joined power sector in 1980, 15th of April, 15th of March, sorry, as a junior engineer. I worked in Agartala 132 kV grid substation for about, say, 1.5 years. Thereafter, I got promotion to the post of assistant engineer and went to Komolpur electrical subdivision. It was inaugurated by me only first. I was the first assistant engineer there. What was the condition then? Condition was very bad. I had to maintain a line more than, say, 150 kilometers, right from Ambassa to Kamalpur. That is the 11 kV line. There was no 33 kV line. After spending 3 years there, a 33 kV substation was set up. So every day a fault used to happen, long line. Every day I had to run. Initially, I had to run myself because to get knowledge of everything. But anyway, fault was a regular phenomenon. Fault was a regular phenomenon because you cannot maintain 150 kilometer 11 kV overhead line throughout the month, throughout the year. Very reliable. It is impossible, next to impossible. Simply next to impossible. Anyway, with the passage of time, things improved. From 33 kV substation came up. There now in Kamalpur there is 132 kV substation. So with this with passage of time, the implementation of some higher voltage substations have lessened the problems and lessened the fault, occurrences of fault. Now at least people get a better and stable power supply. You can ask me a question, please. I will be glad if you ask a question to me. I will really be glad. Whatever you want, you have in your mind, you can ask me. I will try my best to reply it back. And if I can't reply it back right now, at least I will give a feedback later on. So you are most welcome. You can ask. Don't have any question. Anyway, let me go to the next point. I would like to get an answer from any of you that what are the segments this electrical engineering uh, in electrical engineering, what are the segments involved? Please let me know. What are the segments involved in the entire electrical engineering system? Anybody of it? What are the segments in electrical engineering?
Generation, transmission.
Tell me, at least somebody tell me. Please. Distribution to where? Okay, good. So basically, electricity, listen, electricity generates, it travels, it reaches to the users, and it is exploited by the users. And since we know that there is no destruction of energy, so ultimately electricity converted into different kinds of energy, light, heat, motion, mechanical, many things. So it's generated somewhere, it takes birth in one place, it travels to another place, and it serves to many users, end users. So, and in the entire process, generation, transmission, thereafter distribution, and end consumers or end users. So this is the process. The subject so vast, subject is very vast, very complex, very critical, and very challenging also. So today I would like to give you a introduction about the distribution system.
Yes.
Is there anybody who have seen the power plants in Tripura? Anybody here? Which power plant? Ramchandra Nagar. You have also visited power plants, yes? OTPCs. Okay. What kind of power plant OTPC is? Gas-based thermal power, but something you have not, you have missed something. Something else is there. Gas-based power station, but cogeneration. Because that is not only gas-based power station, it is cogeneration, means power is generated through gas as well as through steam, because the output of the gas-based plant is utilized for generation of steam. So it is cogeneration. Ramchandranagar is also combined cycle power plant. Okay. Anybody has any question on this slide? typical electrical supply from generator to customer. Just have a look carefully. This is a generating station. Okay. From generating station, step up transformer. This is 1,38,000 volts transmission line. Again, this is a step down transformer. Step down transformer, step down to 4,000 volts for industrial consumer. And this transmission line goes here again, transmission substation. Therefrom, it is again step down to 440 volts. See? Then distribution substation. Now 1,38,000 volts, 13,800 volts. So it was 1,38,000, that was 20,000, stepped up to 1,38,000, and ultimately again reduced to 13,800 volts. Okay. You see, step down again 120 volt to 40 volts. 13,000, this 13,800 volts comes here, step down 120 volt to 40 volts. Residential consumer. So how the generation at 20,000 volts stepped up and again stepped down and reached to the end users in the form of 120 volt to 40 volts. This is a typical diagram, how it reaches up to the end user at different stages. Okay, is there any confusion about this thing to your mind? Any question also? No question. See, nowadays, the utilities are known as GenCo, then DISCO, then TRANSCO. DISCOM, TRANSCOM, GenCom. Generation companies GenCom or GenCo, transmission company TRANSCO, and distribution company DISCOM or DISCO. And now all these entities are separate. Earlier, when I joined Tripura Power Department, then all the entities were under a single body. Now the entities are different. Management is different, totally different. One does not have link with the other. The same thing more or less. See, you please have a look on this. This is bulk power source, sub transmission, distribution transformer. These are all distribution transformers. Do you have any idea what is three-phase power system? What is the voltage? Three-phase voltage in distribution system. Can you tell me? What is the three-phase four-wire voltage at distribution level? No. Actually, see, I'm telling you in a very simple way. Suppose in Boromuda, the generation voltage is 11,000. That is 11 kV. Then this voltage level is stepped up by 11 to 132 kV. Okay. That 132 kV travels to Agartala, step down to 132 to 11 or 132 by 33. Then again this 33 kV is distributed to different load centers. In those load centers there are substations. 33 kV is primary, you can say primary distribution. But after it goes to those substations, again from those substations, 33 kV by 11 kV. So 11 kV is the primary distribution. When you walk, when you go by car, or when you travel to a road, you might have noticed that feeders are going, 11 kV feeders, and after certain interval you will find one transformer. So from the transformer, the low voltage line is connected. That is the distributor. An 11 kV line, that is the primary distributor. Then from transformer, the low voltage line is connected, that is secondary distributor. And from those lines, the service mains goes to the end users. Is it clear to all of you? Clear?
Sometimes we saw around million hours. And there are basically, if there is three phases, so there are three wires. But sometimes we notice that in each cross arm, there are two wires present. That is, for three phases, six wires will.
See, if it is a double circuit line, then there will be 6 lines. But in railway traction, you will find 22 kV. For 22 kV, you will find only 2 lines. You got my point? For railway, in Tripura, in railway traction, there will be 22 kV. Okay, so you will find only 2 lines. And if it is a single circuit, you will find 3 lines. If it is a double circuit, you will find 6 lines. You got my point? Then, any question, please? Any question, anything? Whatever you want to ask, you can ask. Whatever. If you don't ask, then purpose of my coming here is nil. You can ask something. Anyway, no matter. Is it clear?
Let us explain this one switching station.
See, switching station. Suppose you cannot let an electricity with a specified voltage travels 1000 kilometers to give you an output there with proper regulation. Okay, you cannot expect to, because you know there are many things in between. Reactance is there, resistance is there, and you have to suppose this is a sending end voltage. I am sending this voltage to you. You are at the other end of the line. You must get the voltage at a proper level, at proper regulation. So, switching stations are required in between. And moreover, switching stations are situated or done in such a way that adjacent to those switching stations, at least you are going to get some bulk loads also. So that's why you will find that in some stations, suppose 132 kV line is going, that 132 kV line will be stepping down to 33 kV to 11 kV, but from the same bus, 132 kV maybe stepped up to another 220 kV. Okay, and then again it is fast for stepping down in the next phase. But in the switching station normally is not a load center. Switching station is not at all a load center. You see here is a switching station, right? Switching station, primary feeder. Okay.
Sorry, this totally separate from distribution substation.
Yes, distribution substation. And switching station, you know, in the high voltage transmission system involves switching station, because you cannot ensure with proper regulation and proper level of voltage and electricity at a very distant place. If you send it here, send it from here, so that is required. But is it clear to you? Clear? Any other question? Okay, by the way, all of you are very much aware about transformer. Okay. Now, I'm just asking, any of you may answer. What do you mean by rating of a transformer? Rating. What do you mean by power factor? What do you mean by rating and what do you mean by power factor?
What is power factor?
What? No, this is not at all a good answer. Power factor, it's no doubt a factor, but what it is actually? This is the factor which defines the actual utilization of power or the actual power utilization. This is the because it depends on character of load. It depends on character of load. Am I wrong or right? Correct. So power factor, I have seen that if I ask what is power factor, most of people say it is a cosine of such and such and such. But that is not the point. Actually, power factor defines the actual or active power in a circuit. How much power has been utilized in that circuit? Because there is a reactive component, and and power factor depends on character of the load. Character of the load. Suppose inductance, capacitance. So these are the characters of the load. And rating, why motors are expressed in terms of HP and kilowatt, okay, and why transformers are not termed in terms of kilowatt, why it is kV? Loss, what is the formula of loss? That is in transformer. Okay, you are talking about equipment, but I am talking about distribution sector. What are the formula? What is loss? In line, what is loss? No, I am asking you, how do you express loss?
Suppose I'm sending
No. Loss is I squared times of R. I squared times of R. I squared times of R. That is the loss. Okay. The generator produces 11 kV to 15 kV. This, however, is raised to 220 kV, 400 kV for the long transmission time. This power is conducted over 220 kV, 400 kV transmission lines to switching stations located in the important load area SAR. When the power reaches the switching station, it is stepped down to 132 kV to 16 kV for transmitting smaller quantities to substation.
Can you say Sujol or substations switching station? Can you say?
Surjamuni substation, yes, switching station. Definitely, but Surjamuni Surjamuni Nagar substation, if you take figures of the feeders catering to the load, you will find it very negligible. Very negligible. Because that is not a basically that is not a load center. That is basically not a load. See, 33 kV feeders are less, 11 kV feeders are less, and the area Surjamuni Nagar is feeding, it is not the central area. So there are certain feeders, but from Surjamuni Nagar is feeding other important substations at load centers. Surjamuni Nagar, you cannot say a load center substation, but it is feeding power to many substations at load centers at different levels. Each substation feeds its local area by means of primary distribution feeders, some operating at 33 kV or higher. This is generation level, step up, transmission level, okay, step down. If this transmission is going on, step down for local area centers. This is serving here, this line goes elsewhere, it is serving elsewhere. So this way, the system is continuing. Now, for distribution sector, radial distribution is there. All of you know radial distribution is there. Okay, radial distribution is not very much meaningful. So Riemann distribution is there. And I have already told you that you see in your campus soon a very good power system is going to be implemented in your campus. I have heard today that almost 83 lakh of rupees deposited by Techno College administration to power department for having a 33 kV line through underground cable at the intake. Okay, after that there will be lot of electrical engineering activities. I am telling each of you during the execution of this project from 33 kV up to the 240 volt level. If all of you very sincerely devote yourself to this work during execution and try to learn something very sincerely and very devotionally, I am sure you will learn lots of engineering. I am confident about that during execution. But you have to be very devotional, not overview or not bird's eye view. Then you can definitely, I am telling you, because lot of things will come up here very soon. And I have seen the entire scheme. I have seen the entire scheme. I do not know who has prepared the scheme. Maybe some Kolkata people. Okay, but I have seen many things are there. Even I have seen in that scheme, overhead bus duct is there. Normally in Tripura, if you go throughout the state, you won't find any overhead bus duct other than in power stations. Only in power station you will find bus duct. But this scheme has considered overhead bus duct. From the transformer, the bus duct will go and terminate at the terminate at the receiving end. Bus duct আমি আর কখনো দেখিনি কোনো মানে distribution sector I have never seen.
Sir, what is the function of this bus duct?
Bus duct is nothing but a, suppose in place of cable or wire, you take it to bus duct. Confined bus duct. Just you see this scheme, very nice. And moreover, this scheme will have total ring main through RMU, ring main units. It's a very, very good scheme. I have seen. That's why I'm telling all of you that if you involve yourself, you will be able to learn a lot of things. Lot of practical things, and when this will be executed, many things which are not clear now conceptually, those things will be clear when you will execute it. Concept and knowledge are given by your professors. Okay, concept and knowledge, but synchronizing of the concept and knowledge with the practice will come up through you only. They cannot give you. That will come up through you by your own association, involvement, and devotion. I'm telling you one thing. Suppose in any system, maybe it is distribution, maybe it is transmission, maybe it is generation. I have worked in generation for long 5 years with French engineers. In Tripura, the first gas turbine was commissioned in 1985, and it was a 8 megawatt power station in Boromura. installed, commissioned by Hispano-Suiza from France. The second unit was commissioned jointly. Gas turbine was supplied by Hispano-Suiza and alternator was supplied by BHA. Third unit also, gas turbine was supplied by Hispano-Suiza and alternator supplied by BHA. So in whatever field is there, there are three things. One is if you set aside this, if you just keep it apart, design, then comes your construction, then comes your operation and maintenance, and any system comes commercials. Any system comes commercials. Suppose in a distribution system, say 3 engineers from Techno India, after their graduation, got job in any utility. Now one has joined and he has been given or she has been given the assignment of commercials. The other has been given the responsibility of O&M, and the third one is given the responsibility of construction. So there are, somebody is with commercials. Commercials means all revenue management. That means it will, how much energy you have sold, how much energy you have billed, how much energy you have collected, how much energy you have lost, and what is ultimately at the end of the day, what is your business volume. Because if your business volume is not good, no company will be able to survive or sustain. Am I wrong or correct? Okay. And another is, suppose operation and maintenance. Operation and maintenance is totally different from the commercials. And the other is construction. Now, suppose if somebody is given the responsibility of construction, you tell me what kind of knowledge you must possess for that. What kind of knowledge you must possess for that, or what kind of knowledge you have to gain or to implement your knowledge into field. For suppose somebody who has gone for construction, he or she must have a very thorough knowledge or try to develop a very thorough knowledge about the about the materials, or he or she will have to develop the knowledge of construction standards. What are the standards as per Indian Electricity Rule or Act? Okay. Similarly, who will go for operation and maintenance? He or she will also have to have that kind of knowledge about material, about different electrical clearances, okay, and different tests which are to be carried out during any malfunctioning of the system. And the commercials, that means it is absolutely revenue. Now you see, in our country, most of the discos and discoms are suffering huge losses. Do you have any idea what these losses are and why the discoms are suffering for losses?
They are unable to recover their bill amount. That is, suppose a consumer has multiple customers, the pending
Okay, I have got to some extent. You have tried to give the reply. Suppose you have suppose Techno College of Engineering is a discom. Techno College of Engineering has bought 10 units of energy from KCCL for supplying to Techno India's consumers. Okay. Now this 10 unit I have received. Out of these 10 units, how much units I have billed? And out of those billed units, how much units I have received payment. So one is billing efficiency, how much I have billed, okay, and how much I have received. And one is collection efficiency, how much amount I have claimed and how much amount I have received. So there are two efficiency. One is billing efficiency, another is collection efficiency. So billing efficiency multiplied by collection efficiency is my units realized. Got my point? So the rest is loss. So the if the loss gradually increases, can you run a business? You cannot run a business. So this commercial sector of any distribution company is a very, very complicated field of engineering. Very, very complicated field. Because you have to deal with so many stakeholders. You have to be very, very vigilant. If you now take information from KCCL, you will find that in all subdivisions, one is O&M manager, the other is revenue manager. Because this is a very typical subject. If you cannot earn sufficiently or adequately, your company will be at loss. You cannot run. Where from the money will come? Where from the fund will come? So most of the discoms in our, and not only that, you have to, this is one part. The other part is reduction of losses, distribution losses. I square times of R. Okay, so I square times of R is to be lessened to make a company sustainable for the business. Any question? No question. Do you know what is the highest transmission voltage prevailing in our country? At which highest voltage transmission of electricity is being done in our country? Here it is given. Just have a look. We have heard, most of us have heard 66 kV, 132 kV, 220 kV. Have you heard 800 kV, 765 kV? Heard? Huh? 765 kV DC transmission, 800 kV DC transmission. In our country, it is happening. Not in Northeast, but in the other part, western part, southern part. Low voltage, you know, at your home, where there are three-phase supply, it is 415. Where there is single-phase supply, it is 230 or 240. You divide 433, 400. See, in our state, the voltage ratio of transformer is 11,000 by 433. That is the standard ratio of distribution transformer. Whatever rating it may be, 500 kV or. In our state, distribution transformer, we normally recognize up to 500 kVA. But distribution transformer level is considered up to 2500, 2.5 MVA. This is high voltage HVDC. See, how much? 800 to 1400 kilometer distance. You see. This is the mains extended to your home. This is the feeder. These are the feeders. Source. Is it clear to you? বলেন নাকি পরিষ্কার? Tell me. Sir? আমাদের যে ডিস্ট্রিবিউশন সিস্টেম আছে, the three-phase four-way distribution system, it is the most economically and technically most convenient system of power system distribution. Three-phase four-way. So in our everywhere in our country, it is three-phase four-way distribution system at the distribution level. And in our country, the frequency is 50 hertz. In Europe also, frequency is 50 hertz, but in United States, the frequency is 60 hertz. Do you know about it? Frequency? And what is frequency? Where this frequency actually develops? Where from this frequency? You have heard frequency, everybody knows frequency. Where does it develop? বলো ফ্রিকোয়েন্সি কোথায় ডেভেলপ করে? So you ask your professors where frequency develops. Okay. So in our country, frequency is 50 hertz. In Europe, it is 50 hertz, and in United States, it is 60 hertz. So naturally, you may have a question in your mind. Today, I cannot explain it to you, but you may have a question in your mind. Why it is 60 hertz and why it is 50 hertz? What is the background behind that? I think your professors will definitely, they can easily make it clear to you.
Maybe one point is there. If we follow that 60 hertz,
Ah.
the size of the machines will be bigger.
Yes,
compared to-
from design point of view. Very right. But actually, it is historically, it has been developed. Some people thought that, okay, we will go by 60. Entire Europe and others have gone by 50. So that is from design point of view. You see here. Primary distribution, say it is a 11 kV feeder. Okay. You see this is 11 kV. Okay. After 33 by 11 kV. Substation. Then substation. This is a substation. This is big consumers and 33 by 11 kV substation. Is there anything wrong? Can you understand? Any question? You see, delta star, three-phase delta star distribution transformer. The transformers you mostly and very often you see on the roadside, these are all delta star. Not star delta, delta star.
While we are transferring, there are basically three phases. But neutral wire is not there. While we are sending during power to the consumer, there is a neutral.
No, any transmission system must have a earth. Any transmission system must have a earth. Because otherwise, what will happen in the time of earthfall? There will be no path. Any transmission system should be earth. This is also transmission, but it is not called transmission, it is distribution. But power transmission, okay. And this part is delta, there is no neutral wire. Okay, this is transformer. But the transformer is fed by a system which has earth. Here it is solidly earthed, the secondary side is solidly earthed. Secondary side is solidly earthed. Transmission is star transmission, but it is a delta star transformer. This is RYD neutral. How the connection is given? Any question?
Says your mentioning delta star transformer. Candidate of star, what is this kind of transformers use case?
Yeah, delta is also there. Star is also there. We have star transformer also. From protection point of view, this is good. We have some star transformer at the transmission level, not at the distribution level. Distribution for protection point of view. Protection point means schematics. What kind of schematics you are going to implement? For that, star transformer is also necessary. We have star transformer, but at 132 kV level, star transformer. Is it clear? Overhead versus underground system. See, public safety, initial cost, flexibility, faults, appearance, fault location and repair. We have overhead system in Agartala city and your suburbs also, as well as there are underground systems. Now there is a comparison between these two systems, both technically as well as economically, and from maintenance point of view. What do you think? Which is more preferable? Pardon?
In some points, aerial system is better. In some points, underground system is better.
Tell me a few points.
In case of water, over system it is easy to detect. Underground system in aerial system, there is any kind of hazard possibilities are there. Underground system, this possibility probability is less.
Actually, it is not true that to find out a fault in the underground system is hazardous, not that. It is also easy because there are fault locators. Okay, fault locators are there, but to take up work in the underground system is difficult, which is comparatively much easier for the overhead system. Cost-wise, underground is much costlier, but in terms of stability and reliability, underground is much better. You see, I am sharing you with some experience. During my long 5 or 6 years of working experience in Agartala as a superintendent engineer under West District, I have laid so many length of cables. A cable, I have never found during my entire tenure that a fault has taken place either of the inherent defect of the cable or from any, uh, uh, I mean, foreign element. But every time, whenever there was a power supply disturbance in any part of the city, I every time have found that was not our fault. Either a JCB has cut down the cable, or I have never found, but people were very unhappy because power supply was unavailable. But I am telling you, not a single case I have found either a cable joint has failed or there is an inherent defect in the cable, not from manufacturing point of view, not from construction point of view, not from your cable jointing point of view. I am telling you one thing. Before my retirement, I was posted Udaipur for a brief period. There we have installed one semi-indoor 33 by 11 kV substation. What is semi-indoor substation? Semi-indoor substation means your entire control except the power transformer will be inside the room. No, the substations which you see usually, these are all air insulated substations. This is called AIS. You know very well, air insulated substation, where all the equipment like CT, PT, breaker, bus bar, towers, etc., everything remains outside. Okay, only the breakers, 11 kV breakers, it remains inside, rest is outside. But in semi-indoor substation, everything will be inside. In a particular 33 kV breaker, CT, PT, everything incorporated in a panel. So only transformers will be outside. Only transformers. A 33 kV line from জায়গাটা নামই ভুলে গেলাম, মানে উদয় ফ্রম সে 4.5 কিলোমিটার ডিস্টেন্স, a 33 kV line through underground, 400 square mm, 400 square millimeter, 33 kV cable, 3 core. This cable has come up 4.5 kilometer up to Udaipur Central, terminated for the substation. See, it was commissioned in 2000, early part of 2017. As on today, not a single fault, not a day, not a, no fault, no fault. But everywhere when you find that cable burst করেছে বা cable নষ্ট হয়ে গেছে, be sure that most of the cases JCB is the reason. Most of the cases JCB. But blame comes on us. But blame comes on us. Huh?
There is also a problem, the internet connectivity, fiber, due to fiber. So that might be a reason
Yes.
for this.
Isn't it? Why it is happening? So because mal coordination, lack of administrative and managerial directions. Mal coordination means no work in Agartala municipality area should be held without coordination among the stakeholders. Because suppose you are laying a 33 kV or 11 kV underground cable. There are many stakeholders, PWD, DWS department, BSNL, gas pipeline, Reliance network, Airtel network, many networks are there. So there must be coordination and there must be a master map or master something like that. Means whenever you are going to lay any utility, if Tripura Natural Gas Corporation Limited wants to lay a pipeline, he must seek permission or he must consult with all the stakeholders and obtain the existing route of their of that particular utility. Then we will assess, yeah, we have some space here, we will go by this way without affecting anybody. So where there is some problem, then all will come, all will decide jointly. But it is not happening here. In Agartala Smart City, you see, I was associated for some time with Agartala Smart City work. There also I have seen in this road from Nichubagan to airport. I was associated for some time. Almost on each alternate day, I used to get a call. Sir, ওখানে তো কেবল জেসিবি কেটে ফেলেছে। এই বেশি দিন আগের কথা নয়, only a year or 1.5 years back. So this is due to man coordination. এই কথাটা আমি এই কারণে বললাম যে most of the cases power engineers or electrical engineers are blamed, but actually they have nothing to do because mechanical abuse by other departments caused the failure, not by us. This is radial system. But in your campus, the scheme which is going to be installed will have no radial system. It will be a ring main kind of. Why don't you
Can you,
show?
sir, explain some ring main in it?
No, just 1 minute. Why don't you one day just assemble all of them and show the scheme, and then they will get interest. The scheme is very nice.
Sure, sir.
Actually, আমি দেখেছি তো স্কিমটা খুব সুন্দর, খুবই ভালো। তো কি what you all?
Sir, can you please explain the RNU ring main unit system for the student that if it's drawing is required, you can access.
Ring main means ring main unit is a combination of a few circuit breakers, and load breaking switches. It is a combination of circuit breakers and load breaking switches. Ring main unit is nothing but combination of circuit breakers and ring main load break switches. Ring main means the drawing আছে এখানে আছে আচ্ছা see this is a substation, okay, and distributor primary ring, distributor load, distributor load. Okay, you see this is the substation. A fault has occurred here. This is a ring. This is a ring. A fault has occurred here. Less voltage fluctuations at the consumer, at the system is very reliable, and each distributor is fed via two feeders. Now you see, this is distributor from this side as well as from this side. See? But had it been a radial, only one source. Had it been a radial, only one source. Am I clear? This is the substation. This is a fault occurred. This is a distribution transformer. From this ring, this transformer is getting power from this ring, giving it to loads. This is another distributor. This is a transformer giving loads. This is another transformer taking from this ring, giving loads. This is the distributor. Now, if this fault occurs here, each and every distributor has an option to get power from two sides. But in case of radial distribution, you won't get. If there is a fault, this entire line is off until and unless the fault is cleared. So ring main distribution, it is a just basic, conceptually developed the basic schematic arrangement. This is a ring main. So in your campus, what is going to happen is a ring main. কবে নাগাদ হবে শুরু কাজ করবো? হ্যাঁ,
4 to 5 minutes to go.
do you have any question? No. Is it clear? You see, two substations. There was only one substation.
So it is
When the-
better than the RMU ring main unit systems.
Pardon?
Is it better than ring main unit system?
See, if there are two substations, obviously the reliability index is more, obviously. This is one substation, that is another substation. But it is ring. It is the ring. Source of power from 2 points. But the ring is fed by two sources. The other was ring was fed from one source.
It is much reliable than ring main.
Yes. Distributor loads, distributor. It increases the service reliability. That is what we have asked. Any area fed from one generating station during peak load hours can be fed from the other generating station. If you consider these two sourceless two generating stations, from same source, if two feeders come, that is not a dual source. Source means the source of power is totally different. This reduces reserve power capacity and increases efficiency of the system. Efficiency of the system. Much more efficient. Any question? See, I told sometime that any distribution system requires proper regulation. What is regulation? Regulation means if you send X amount of power from one point to the other point, that X amount of power should be transferred to the other point with proper voltage level. And in the process, you will incur some drops, voltage drops, but that must have a limit. As per Indian electricity rules, in the distribution sector, the voltage regulation is plus minus 6%. Plus minus 6%. So, if the declared voltage of an utility is suppose 230 declared, then it must be either 230 plus 6 or 230 minus 6. And you see all the manufacturers of light, fan, all domestic utilities, they go by the standards. Suppose 11,000 by 433. If you divide 433 by 1.72, how much does it come? Just have a look. What was it? $433 by, does it come to 50? Now 433 by 1.72. আর 433 টা তো থ্রি ফেজ ভোল্টেজ আর 1.72 ভাগ করলে সেটা আসবে হ্যাঁ 250. Now you see, if the transformer is 11,000 by 433, that means secondary is 250. If you purchase a bulb of 230 and if that bulb is subjected to 250 volt all along, its lifespan will gradually go down, because 230 plus 6%, how much does it come? 230 plus 6%?
13 plus
230 plus 6%, 244. So it is more than 246%. This is very important. So voltage regulation is two types of voltage regulation.
If we get less than the 216 volt, so what if it is machine lifespan will be decreased also?
Now, in case of if it is a motor, then what will happen? The motor will always try to maintain its horsepower, and it will draw from the system more current, and eventually it will burn. That is the difference between resistive load and motor. If the voltage is less in a light, power will be less, illumination will be less. Okay, but if the voltage is less in a motor, the motor will try to give the required torque. So what it will do, it will draw from the system more current, and in the process it will burn. Where power factor plays a very important role. Power factor plays a very important role. Pardon?
We are paying for the amount of current we are donating from the supplier.
বুঝতে পারি না কথা, you have got my point. Suppose it's a motor. It is three-phase 4-wire but three-wire motor, 415 volt, plus minus 6%. Okay. Now minus 6% means 415 minus 6%. Say 380. Say if the voltage level goes below 380, motor is designed for 415 plus minus 6%. But when the voltage level will go below 380, motor will try to maintain its torque. So it will try. When it will try, it will draw from the system more current. Okay, and in the process it will burn. To maintain its torque, it will try. মানে সে আরো চেষ্টা করবে বেশি নেওয়ার জন্য, তার ক্যাপাসিটির বাইরে নেওয়ার জন্য। You got my point? ওই কথাটা আমি বলেছি। And you pay for energy. This is energy means voltage and current.
So that voltage will be reduced then if it is
Yes,
voltage will be reduced.
yes. It is একমাত্র in
That
case of
our-
voltage.
Okay.
In case of voltage, if it reduces, motor will take more current. এই জন্যই কি বলে যে লো ভোল্টেজে হলেই লিমিট সুইচ ফাঁকানো যায় বড় বড় ইন্ডাস্ট্রিতে when the voltage falls below preset value immediately the motor will be disconnected, otherwise it is risky, motor may burn.
So in Tripura, if the voltage is down the less 6%, then who will be responsible?
Because the licensing in the supplier who is giving you power supply. But in Tripura, overall voltage profile is good. আজকে এখন এরকম শোনা যায় না, আগে আমরা অনেক জায়গায় খুব লো ভোল্টেজ হচ্ছে। Now this problem is more or less eliminated. Why it is eliminated? Tell me. How it is eliminated? একটা কোশ্চেন, সাপোজ তুমি যখন এখানে থাকো, where you are staying, you just remember 15 years back there was electricity in your home. Now you just think that 15 years back what was the level of voltage profile, now what is the level at your
Maybe
home?
tap changing.
No. Tap changing is different issue. But why? I'm telling you why tap changing. Tap changing, why has it improved? Tell me. আর তোমার মনে যেটা আসে সেটাই বলো না, কি মনে হচ্ছে কেন হলো এরকম? এরকম আছে না, যেরকম অনেকে এখানে আছে হয়তো they have some experience that 15 years back the voltage at their houses was a little more, a little less, but nowadays the voltage is good. I think most of you have some experience like that. So you ask yourself that কেন এটা এরকম হলো, কিসের থেকে হলো? কি দেরি হয়ে যাচ্ছে? Pardon?
Industry use synchronous machines basically. And they know the
এটা হয়েছে only for the system has improved. আজকাল তো হয় না কম, তো system has improved. Means how the system has improved? More 33 kV substations have come up in the load centers. Backup 60 kV substations have come up. Backup 132 kV substations have come up. আগে সাপোজ সিস্টেমটা আগে একটা জায়গা থেকে অনেক দূর অব্দি দেওয়া হতো। Now more substations have been set up in the load centers.
That is constructively
Yes,
construction also.
the system has been modified. এই জন্য এটা হয়েছে। আর যেটা নাকি ট্যাপ চেঞ্জিংটা কি হয়? ট্যাপ চেঞ্জিং এ এভরি ডিস্ট্রিবিউশন ট্রান্সফরমার যেগুলো আজকাল কেনা হচ্ছে, এভরি ডিস্ট্রিবিউশন ট্রান্সফরমার আপ টু -5 to -5 to +2.5 or +5 ভেরিয়েশনটা থাকে আর কি, in each of 2.5% step. In each of 2.5% step, suppose principal that is there 11,000 by 433, on the plus side 2.5, on the minus side 2.5. So tap changer can be used very effectively if locally some problems develop, but you have to keep a watch before changing the tap, the level of voltage at various times of the day, then you have to change it. এরকম বহু জায়গায় হয়েছে, এরকম আমাদের দেখা যায় ভোল্টেজ কম আছে তো ট্যাপটা চেঞ্জ করে দিয়েছি, ওকে, নো প্রবলেম। But you have to know the technology, or you have to know the skill of converting the tap changer. Most of people I have seen, many engineers I have seen, জানেই না কি করে ট্যাপ চেঞ্জিং করতে হয়। They have never done it also. Tap changing is there. আমাদের যত ট্রান্সফরমার আছে excepting 63 and 25 kVA, maybe 100 kVA, 200 kV onwards, 200, 315, 500 tap changers are there. You can utilize at very remote area. হয়তো দেখা যাচ্ছে কোনো কারণে একটু হচ্ছে, এখানে ওই যে রেডিয়াল ডিস্ট্রিবিউশন হলে কি হয় সেটা দেখানো হয়েছে। I1 minus, I2 plus 3, I2 minus, I3. And here you see number 2 indicated. ওই কনসেপ্ট থেকে এসছে।
In Tripura, normally we use the radio.
হ্যাঁ,
In Tripura, we used
নর্মালি তো আমাদের একটু রেডিয়াল মানে কি হয়, যেমন ধরো রেডিয়ালি বলা চলে, তবে কি সাপোজ একটা সাপোজ ওয়ান distribution system NCR, another distribution system from another substation NCR. Okay, there is no connectivity, so it is radial. But in case suppose if a particular transformer fails, it takes time, they connect it and provide supply, but it is not a ring main.
there is an option.
There is option there, but it is mostly radial. This distribution system is mostly radial. Important places like Secretariat, like I do not know, maybe High Court, like Secretariat. In some other places, this is radial to underground. RMUs are there. Where there are RMUs, it must be radial, ring main. So wherever you have utilized RMUs, it is ring main, because it is a combination of load break switch and breakers. Combination is suppose 1 incoming, 3 outgoing, maybe 2 incoming, 2 outgoing. So this is a combination. You will use it according to your requirement. Any question? But ব্যাপারটা হচ্ছে কি, see, learning has no end. Okay, and whenever we suppose today I have been given an opportunity by your authority, so when we come and discuss, sharing of thoughts enriches people. That is the thing. And I am dissociated with my own profession for the last few years. Okay, and recently I am totally dissociated from my profession. I am associated with food industry. I am associated with food industry and associated with some policy level decisions at PIDCL. I'll tell you what is the role I am playing there. I'll tell you. এই জিনিসগুলো দেখা দরকার। Each and everybody, whenever you walk along the roads, whenever you go somewhere, because all of you are electrical engineers, whenever you go, whatever construction structure, whatever you see, you please try to identify what these items are, and synchronize with your classroom lectures with the components. What are the components? What is a tower? What is a pole? What is conductor? What is insulator? What is gang operated switch? What is isolator? What is this insulator? What is pin insulator? What is the associated hardwares? This is just a standard design of a overhead roadside distribution substation. You always see at the roadside. Then precast cement concrete poles are there. RCC poles. See. This is a 7.5 plus. Because any pole, in distribution sector, any pole, it is a standard practice that 1/6 of the pole length must be embedded into the earth. 1/6. Am I doing good or bad? Six See, you please try to find your answer here. Just see. You try to find your answer here. You ask me something. You find your answer here. You got your answer? Okay. Have you noticed this? You see each and every part of the insulator and how it is fixed with the wire has been detailed here. Suspension insulator. In 132 kV line, or suppose in 132 kV line, what is the phase voltage? Yeah. It is a subject ক্লাসে পড়ানো হয়। Heating efficiency, these are very theoretical. No need to any question. And I will now tell about what is the industry, what I do in Tripura Industrial Development Corporation Limited as the director of the board of directors. See, Tripura, all of you know that Tripura is a state which is cut off from the mainstream of the country. It was very dangerously cut off, but now for the last few years, a lot of improvement has taken place in terms of railway communication. Roads have been made good and some alternative route is also done. Especially many airlines have started coming. So by airways, by railways, the system has improved. But by roadways, it is yet to improve. Now, Tripura is cut off from the mainstream of the country till now. The people of the mainland states, the benefits, the amenities, the other facilities they enjoy. Do you enjoy? Do you enjoy? Do you enjoy or not? Tell me. Can you enjoy the benefits the people of the mainland states enjoy? Do you enjoy? You do not enjoy. So, if you want to develop our state industrially, that means what do you need? Tell me. Infrastructures are to be made good. That is correct. Infrastructure. But suppose you have good infrastructure, but still you don't have investors. You have good infrastructure, but infrastructure means your roads, airways, railways, logistics, warehouses, and etc. etc. But you don't have investors in your. Why investors are not coming here? Policy is one of the things, but the industrial estates. Every state has some industrial belt, industrial estates. If the industrial estates are not built with all the modern facilities to make it investor friendly, because a person who is in Delhi and who is going to get all facilities for his investment, for production of anything, will he or she come to Tripura if you cannot provide at least not that standard, at least 90% of the standard they are enjoying elsewhere in our state? Nobody will come, because investors will come only when they will get an investor friendly environment. To invest his money for something productive. This is one point. The other point is what sort of industry will come in this state. You cannot make anything here. You must have to study the demand. You must have to study its viability, its marketability, its, I mean, profitability, whether it will give you or it will yield the required benefits. So in Tripura, the nodal agency is Department of Industries and Commerce. Department of Industries and Commerce is the executing agency. Nodal agency is Tripura Industrial Development Corporation Limited. What is the objective? That promotion of industry, development of entrepreneurship, development of skill. Entrepreneurship, why? Because the young generation, they should come forward. See, in our state, after engineering graduation or any graduation, everybody seek for a job. I also did the same thing, but I never, or my colleagues never, those my classmates never thought of any developing entrepreneurship. Government job is limited, private job is limited. Entrepreneurship is a current subject. Startups are the subjects of the day. So if industrial development takes place, it requires a proper platform where the industries will come up. So government of Tripura, through the industry department, by taking assistance from Asian Development Bank on loan, they are going to develop 12 industrial estates in the state. You know some of the industrial estates here, RK Nagar, Bojjang Nagar. Similarly, in other places, Kumarghat, Panisagar, Dharmanagar, Dukli, Bhojanagar, there are many other industrial estates which are to be developed. So it is a huge plan TIDCL has taken up with the financial assistance on loan from Asian Development Bank and going to be implemented. What these facilities will, what these facilities are: improvement of internal road, industrial estates, improvement of internal road, stormwater drain management, effluent treatment, power supply, uninterrupted power supply, security, safety, all these things. This is almost a 1,500 crore project that government of Tripura is going to implement. The development of all the industrial estates. Besides, for development of entrepreneurship also requires development of skill. So for development of skill, there are extraordinary training programs, classes, and which will invite the young generation to think for development of entrepreneurship. So these are certain things with which I am involved in TIDCL. Got my point? So, and Tripura is a industrially backward state. Here, the most of the students or most of the parents always think that my daughter or my son, after graduation, he or she should get a job. Somehow I got job. That is the main objective of our. No, see,
That is correct.
I'm not going to blame anybody, but how to develop entrepreneurship? Set aside your aspiration for a job. I will do something on my own. Maybe at a lower scale, may not be at a higher scale, but that sort of mentality is yet to develop among the still nowadays. Still, it is coming up. Dhire dhire, it is coming up. But to development of entrepreneurship and development of related skill are two important issues. Now it is required. And see, there are other opportunities too. Today morning, I read Dainik Sambad, and there I have found a very interesting topic that Council of Scientific and Industrial Research (CSIR). If you read the second page of the newspaper, you will find that CSIR has initiated a symbolic fight against greenhouse gas emissions. Symbolic. How? They have decided that once a week, all the employees will come to office wearing non-ironed dress. Why? Just a symbolic fight to show how to reduce carbon emissions. আজকে পেপারেই দেখলাম। So this is symbolic, means greenhouse gas effect তো কোথায় যে এই ফসিল ফুয়েলের কথাগুলো বললাম এগুলো এটাই একটা কারণ, এগুলো আস্তে আস্তে সব স্টপ হয়ে যাবে। সো ফিউচার ইজ solar power, solar or other renewable energy, non-fossil fuels.
Except solar, what is the scope of another renewable energy? Is there any scope?
Small hydro,
Small hydro. That level is the 5
or 5 megawatt. No, small hydro, less than 25.
less than 20.
Less than 25.
And then there is a possibility to wind. Is there any
When
possibility?
Tripura ওটা মনে হয় না কোনো possibility আছে বলে। So actually today I think I do not know, after a very long time I have got an opportunity to interact with some of you on my professional subject, with which I am dissociated for a pretty long time. But if I get some sort of opportunities like this, definitely I can brush up my forgotten subjects for helping you people. You see, when there is dissociation, practice leads to perfection. If you don't practice, how much? I have been retired 7 years back. Okay, 2017 I have been retired. Now 7 years already passed, and I am dissociated with my professional things, associated with some other new things. Still, professional subject is always a subject of interest, but this interest multiplies when there is interaction. So I have found one or two students have definitely interacted. So in future, if I get an opportunity to meet you people once again, I will try to brush up myself at first. Then I will try to brush up you. Actually, so I do not know whether you have liked the interaction or liked the session. Tushar told me yesterday evening that it is a event where some energy and power scenario should be presented. So I hurriedly prepared some sort of data. So those data I have shared with you. And I do not know how much you have been able to remember in your mind. Anyway, but electrical engineering is a very vast subject, very vast, very vast, very complicated, very typical. So with this, I think I can call it a day.
Thank you so much.
But if you have any question, you can ask me. No issue. One more thing I am telling, what is from my experience, what I say, that don't shy. Shyness kills people. Don't shy. Suppose some people I have seen that out of shyness, he or he has a inner mind to ask something, but shyness helps him or her back. That shyness should be avoided. Whatever you have in your mind, simply ask. Okay, that is better. I am telling you, that is better, because we learn through books, we learn through discussions, we learn through exchange of thoughts. Okay, so shyness should always be avoided. It is my personal experience. I do not know whether you will agree or not.
Nowadays, students are very much interested in mobile. Their idea, they will get everything from mobile.
That is true. That is also true.
Thank you very much, sir.
In the beginning, there was much. After some time,
No, it happens everywhere. It happens everywhere that some will leave, some will stay. It happens everywhere. But see, some people leave for two reasons. Either the speaker is bad, or they are not getting interest on the subject. Otherwise, there will be no other option.
Okay, thank you very much, sir, for your wonderful speech. I request all of you to give a big round of applause to sir. I think it was a very interesting session, and the students have uh, like received a very big opportunity to interact with such a person who has got real life experience, who has got real life experience to share with people. Nobody is like, not many people are so much active to share his or her experience with the students, or like anybody, like let it be faculty members, or but sir, he is very enthusiastic. He received our request very positively, and he shared his experience with great joy. So I think it was a wonderful experience for all of you, and you have gained some knowledge. And if you have any query, you can ask now also. Sir is here for a few minutes, because I don't think you will get such opportunity. Okay, so if you have any query right now also, you can ask. Otherwise, I'll wind up the session.
I will just ask those who are present. I will just ask that from the deliberations and interaction, have you even been able to learn a single word? If it is there, then it is okay. Otherwise, my coming over here is totally meaningless.
And yes, it is very like the speaker also feels very happy if the audience is interactive. They get some another kind of energy. So if you have, bolbe kichu, if you want to say anything, you can say.
Now, actually, see, today's event is based on a particular day, particular day, national technology, and the subject was power and energy scenario. Okay, I was not initially known about this. Yesterday only he told me, but I was preparing something that over distribution sector, some interaction will get. But if there is a specific requirement on a specific subject, then I can elaborate in a more better way, and you can also have an interaction as per your mindset or as per your inquisitiveness. So in future, if I get an opportunity, then Techno College of Engineering will only think whether that is required. So then I can go for. But in such situation, the professors should also take initiative before uh, taking some sort of this sort of interaction. They should prepare their students with lots of interactive questions. In that case only, what will happen? Actual learning will take place. Because otherwise, if there are questions, I can satisfy them with my answers, which I will not be able. I will tell it later. In that process, they will learn. Okay. Yes. Otherwise, what will happen if I simply speak and if things are not clear to them, it will not be very fruitful. But I will tell all of you, you please visit all the substations, power plants, see distribution sector, go to the power plants, try to learn, try to make your conception more and more clear. Then in the actual field, you will grow up quickly. Okay. Thank you very much.